We have our next presenter. Kwang Pin is currently a senior consulting systems engineer in the Juniper Networks Advanced Technologies team. While focusing on data center and cloud, in this role, he is responsible to drive Juniper Networks solutions for data center and cloud to customers in Asia Pacific, and to provide customized solution for these customers based on their requirements. But without further ado, we'd like to invite the Director of Sales, Security, Juniper Networks. Let's give a warm round of applause to welcome Mr. Simon Tong.
Today, what I'm going to cover is basically what is SDN, right? Some of the things, why SDN comes about, what are some of the misconceptions of SDN, right? And at the end, very quickly, what security means, okay, in SDN. So maybe a quick show of hand, right? Like what Greg said just now, have some exercise. Who has heard about SDN? Oh, okay. So not too many, right? Great. So what I'm going to do is just to go through a little bit of I won't say history, but a little bit of the reasons why people start to think of why they need SDN, okay, in their network, right? And manually works. Well, I'll do it manually then. So one of the things about SDN is, I mean, whenever there's new technology that comes about, it's always because of some reasons, some challenges that they face in their existing environment. Oh, not some challenges that they face in their existing environment, right? That propels them to do things differently, right? So one of the things that they always have a problem is basically on management. Right. A lot of networks today, especially in the data center, are being done very statically. You do CLI configurations, you map your services physically, VLAN chaining to a different VLAN, making sure the services run accordingly, right? But it's very manual, right? So once you have a lot of services or a lot of customers, if it's a service provider, then you have a problem, right? When you start to scale, you can't scale because a lot of things are manual, right? So what a lot of people wanted to do is basically to make it easier, right? And how to make things easier is to abstract it. Everything that do is software. You don't care what's the bottom, right? So that's the original idea of what people want SDN to do, right? So that's one of the things. And second thing is that being in data center business, okay, you need to provide services fast, right? Now, today you have a lot of cloud services that are out there. You have your Googles, your Facebooks, your Twitters, whatever, right? And they always have to come out with new services. And then sometimes the new services require certain features, okay, from the network, right, in order to support those applications. So a lot of time now, when you ask for a feature from your networking vendor, right, they'll tell you, oh, I don't have this feature. I can ask my engineering to come up with a feature. It's going to take 6 months, 9 months, whatever, right? Very common. So what happened now is that people don't want to wait so long because they want to do things very fast, to make it very agile, right? But in order to do all this today is kind of difficult, right? And one of the reasons why it's difficult is because if you get a router or a switch today, it comes in a box, right? Everything is in a box. You have your forwarding plane in the box, your control plane in the box, your management plane in the box, services are all in the box, right? And then when you want to scale, you have to scale all at the same time, meaning to scale up. Small box, buy bigger box, buy even bigger boxes, right? People don't want to do that also. So what they want to do is, I want to be able to scale the individual components individually, right? So that you can do a scale out. Say, for example, my control have enough CPU, but I run out of ports. I just need to add more ports, right? But because of boxes, what happens is that you have to buy another box and buy another box. And then interconnecting this box becomes kind of difficult sometimes, right? you start to have to add new protocols to make things work together. Right? So all these are some of the challenges, right, that people faced. Right? And then when you start to have so many boxes together, right, 3 months or maybe a year or 2 years down the road, you need to, you have some either it could be some new features that you require or some vulnerabilities that we discover or whatever, you need to upgrade the box. What happens? Right? You have so many boxes, and it's difficult to upgrade, and then sometimes upgrade don't go well, and then it causes the network to go down, things like that, and so confidence level of the people actually goes down because network is not stable. And so all these are challenges that people face today, right? And what people wanted to do is to solve these things, and SDN came out to be, it's like an ideal solution that can solve all these things, right? Because first thing, what SDN is supposed to be able to give you is a decentralized model where certain things are centralized, certain things are decentralized, and you actually have a common management platform, right? And then because certain things are decentralized, you can scale them individually, right? And then when you scale them individually, because they are distributed, when you do any upgrades, whatever, you will not impact so much because your domain of impact becomes smaller, right? So a lot of people think that SDN is like, well, that's the ultimate solution, right? And over the past, a year or two, so many people have been talking about SDN, right? Customers, partners, vendors, everybody is talking about SDN. But the problem is SDN has different meaning to different people. And that ends up being a little bit of a problem because people start to think SDN in their own way. Right? So in Juniper, we talk to a lot of customers. We also have a lot of distinguished engineers who have a lot of who think about this problem a lot as well, right? And we basically think that there are 7 different so-called misconceptions of what people outside are talking about SDN, right? So, so basically, the 7 myths of SDN, right, are what we think are not certain things that people have. It's basically some misconception about SDN that people think, right? So we talk to some customers. They think that SDN is only good for data center, right? And well, it's true that it's probably going to start from data center because they face a lot of challenges in data center, right? Especially on the orchestration piece, or especially on how to make sure that your virtualized servers and storage works well with whatever network you have today, which, well, can't be virtualized that much today. So how to make it work better, right? But the thing is, after you deploy it, right, in a data center, you can expand this knowledge to all the other places. Like what Greg said, your security, you apply the policy one place, you are able to extend it to all the different places, right? It's the same thing with SDN. You start off with data center, you learn how it works, you learn what makes sense, what doesn't make sense, and stuff like that, and you can apply it to other parts of the network, the edge of the network, the core of the network, campus and branch, whatever, right? So it's not really just about data center networking, right? It's more of how you learn and then apply it to the other areas, right? And the thing about SDN is that people started thinking about wanting to be able to save cost, okay, by using dumb switches or dumb routers, right? At the edge of the network, I just use a centralized controller to just tell this guy how to forward the traffic, right? But that probably will save you a little bit of money, right? But later on, I'm going to show you that you can't simplify the hardware too much, right? Because you need the hardware and software need to come together, takes 2 hands to clap, right? So they need to complement each other. So your savings and capex, well, there could be some, but may not be much. Where the real savings is going to come is from the OPEX, where it allows you, right, to be able to do your orchestration much more efficiently, right? It allows you to turn on services faster. It allows you manage your network better, because now things are, some of the stuff are separated, some distributed, some of things are centralized. Right? You make things easier, right? So, so it's not just about CAPEX basically, right? OPEX plays a part too, right? Like I said, it's SDN, right? Software-defined networking, but this is not really just about software, right? You still require hardware to basically help you do certain things, right? So, well, example, say 15 years ago maybe, yeah. When MP3 first came out, right? It used to be you have to use tape, whatever, or CD to play music, right? And then MP3 came out, you can start to, I wouldn't say download music or convert your music into a digital format, and then you can play it on your desktop. At that time, it's all desktop, right? But the thing is, you play it on desktop, and then the CPU starts to go up around 90%, right? You can't do any other work, right? So what happened is that all the CPU vendors, think, oh, why not we offload some of this decoding or encoding of this digital content, all right, into some specific instructions on the CPU. So they came out with extension, multimedia extension and stuff like that. And then when you start to use those CPU to play your MP3, well, CPU is like, well, next to zero, right? 1% maybe. And then you have all the other 99% to do your work. So it's an example to show that you cannot just use normal hardware and just think that everything can be solved by software, right? You need them to work hand in hand, right? So it's not just about software. You still need to spend R&D money into hardware and make sure that whatever you want to do in software makes sense to the hardware, right? The hardware needs to support what you want to do, right? So SDN, just now we talked about, we centralize the control, right? So that at a high level, central layer, you know how to forward traffic. You can tell this guy, you do this, you do this, you do this, right? But does it make sense to centralize everything, right? So obviously the controller you need to centralize, right? Just now I did mention that you have your forwarding plane in your switch or router. So the forwarding plane you can't centralize basically, right? Because you don't want the traffic to come in and go to the central location, come back, because that is going to kill the performance, right? So that cannot be centralized. Management, yes, you need to centralize. Control also needs to centralize, right? If you talk about firewalls, you have services, right? So now services, it depends on where you deploy these services, right? It could be centralized, it could be decentralized, right? It also depends on whether you're using a appliance to provide the service or using a virtualized version of the appliance to provide service, right? Virtual firewall versus physical firewall, right? So we have both, but it depends on where you deploy them. Sometimes centralized, sometimes decentralized. So it's not everything about centralization, right? You have to look at what makes sense, right? And another question, right? Raise your hand. Have you heard about this protocol called OpenFlow? OpenFlow, yeah. So probably about a year or two ago, when people start to talk about SDN, they equate SDN is equal to OpenFlow, right? But I think today a lot of people understand that SDN is not just about OpenFlow. OpenFlow is basically a protocol to allow you to controller to talk to the networking device, to tell them, basically to give them information on how to forward certain packets, right? But SDN is more than that. SDN includes how the orchestration piece, includes how you do all the virtualization of the entire network, stuff like that, right? So you start to have what we call a scenario where people say that you must have, for SDN to work, you must have OpenFlow, right? But that's not really true, because it's just a protocol, right? It's just a protocol to allow us to allow a controller to tell the networking device what to do. But you can use any other protocol as long as it's standardized. The important thing is it needs to be a standardized protocol. Well, OpenFlow is one of them, right? You could use other protocols too, right? But the thing is, sometimes you need other protocols to work hand in hand together, right? Say, for example, you have a network. You want to use OpenFlow to tell these little pieces of networking devices, how to forward packet, right? But before that, the controller needs to understand what's a topology, right? If he doesn't understand the topology, how you tell him how to forward? So he may need an additional protocol to go and find out, the topology. After that, then he can tell the switches what to do, right? And if you are trying to do some kind of traffic engineering, right, what's the controller going to do? He needs to understand the state of the network, where are there any congestion, where is the path that is, bandwidth abundant, where is congestion or whatever, right? So there could be other protocols that are required. So it's entire ecosystem of protocols and systems, right? So it's not just about OpenFlow. You need to look at where you want to deploy SDN, right, and then decide which is the best protocol to use, okay, at that point in time, right? Well, so the last two, right? I usually will talk about it together because one of them basically says, some people think that it's going to happen like now, today, or yesterday is happening, or it has happened yesterday, right? And there's another group say, no, it's not going to happen, right? So what is going to happen is that there are always going to be people who are going to try it, right? And then once they start to try it, and then they learn from it, and then they expand on it, they do tweaks and stuff like that, and then they will deploy it in even more places, right? So IDC did some studies, and basically they said, maybe for 2013, the amount of worldwide business for SDN is probably in the low hundreds of million, maybe 200–300 million, right? But by the time it goes 2016, it's probably going to be around like $2–3 billion. Right? So it's going to go. Just that it's going slow and steady, basically, right? And in the third quarter of this year, right? I just put a year out of it. Juniper is going to launch our SDN solution product for our SDN solution, right? In the third quarter, right? So, but that's mainly targeting for data center in the first place. Like I said, it starts with data center, but we are going to evolve it to the other, to be applicable to the other parts of the network as well. Okay. Okay. So obviously, once we identify what are some of the misconceptions, right? We need to have a strategy, right? To approach the, I won't say it's a problem, to approach this, to approach SDN, right? So we basically identify, some of the principles of SDN that we think are there, right? And then we also spell out some of the steps that we are going to take, right? In order to achieve those what is mentioned about SDN regarding those 6 principles, right? And obviously, because it's going to be a software solution, everything is going to be about software, right? So we are going to also we also introduced a licensing model that makes it very easy for people to deploy, right? Today, if you buy a firewall, right? You want to buy additional services on the firewall, right? We'll ask you for your serial number. We give you a license for the serial number, and you apply it, and then that service works for that particular box, right? So what happens is that if you need to move the services around, you need to move it around, you can't, right? So basically, to make things very simple is we are not going to tie anything to serial number. It's just basically it's like you buy a certain set of licenses, you just apply wherever you need. You don't need, you just take it out and then put it somewhere else. That's all, right? So that's just for licensing. So I'm going to go into a little bit more detail on each and every principle and what are the steps that we're going to do, right? So the first principle is separating the planes, right? I did mention way in the beginning that within the box switch or router you have 4 planes, right? Management plane, control plane, right? Forwarding plane, right? And services, right? So what are the advantages of being able to separate all this together is definitely being able to scale them individually. Like I said just now, you don't need to buy more boxes, that includes everything, right? You just need to scale. Say forwarding plane not enough, just scale the forwarding plane, right? Control plane getting saturated, you know, CPU is very high, memory very high, whatever, just buy more control plane, right? Just add on to the system, right? So you do not need to so-called, you know, expand all 4 planes all at the same time, right? And one of the advantage of this is also later on I'll say about is that you are able to, you know, put the different planes at different places, right? Because it makes sense to put things, some of the things in the central location, some of them away, right? So what are some of the places, what are some of the things that need to be decentralized? Like I said just now, forwarding plane has to be centralized, right? It doesn't make sense for you to, every packet come in, send it to the controller, right? Doesn't make sense at all, totally, right? So that part has to be decentralized, right? Controller management, well, you need to be centralized, right? And you need to centralize the function. But in order to provide HA, meaning high availability, right? You may want to physically distribute them to different locations, right? So the function is centralized, but physically they could be at different places. You understand what I mean? Okay, so basically both of them are doing the same thing, right? No, it's a centralized function. They will, from a central location, they will control, okay, the forwarding plane, right? But in order to provide you with certain level of high availability, you want to keep them at different places, right? So that, no, if say for example power failure at one side, at least the other guy is still functioning. Then your network is still up. At least part of the network is still up, right? You put them together, something happened, catastrophic happened, and then that's it, you lose everything. Right? And then what happens is that when you want to do software upgrades, which always will happen, it makes it a lot simpler. Because now you just need to upgrade the forwarding plane individually, you know, upgrade the management plane, upgrade the control plane. You know, all of them are really fully redundant, basically. Right? A lot of cloud techniques are already available. You know, things like virtualization, all those things, right, are already available and has been available for a long time. People have used it and then understand it. You know, they understand how to troubleshoot it, how to make it work well, how to optimize it, you know, how to make it work very efficiently. Right? Last time used to be, you know, when you run when you start to run, say you put a hypervisor, you know, throughput coming out of the box, right, is not so great. Right now they optimize it such that, you know, you can get near line rate coming out of the box, right? So with all these advances in all these techniques, right, you can also use these techniques. Basically virtualize your services, for example, right? And then being able to do service chaining. I'm going to talk a little bit about service chaining. Greg talked about it a little bit just now, you know, how to chain the services together. All right. And then at the end of the day, you need to be able to manage the entire network, right? So you need to create a common platform, right, where you actually provide, I would say, northbound interfaces, right? So you have the 4 planes, right? You know, you have forwarding plane, control plane, management plane, right, and the services, right? So you need to be able to, through your controller, being able to tell the controller to do certain things, and the controller is able to go to all these different places and then push down instruction to tell them what to do, right? So it's the common platform. It's basically making your network look like a compiler. You know, usually when you write a program, you know, it doesn't matter what C program you write in Perl, or interpreted language Perl, Python, all this. You don't really care about, at the end of the day, how the instruction sets get executed, right? You just need to write, well, at a language that a human can understand, right? So after that, the compiler will do its job. Something similar, right? You define your policies at your management level, right? And then the controller is going to take all this policy and translate it to what needs to be done, whether you need to do the service chaining, how you need to make the traffic flow from one point to another. That's all done by the controller, right? Right. One of the important things I mentioned just now also is that, you know, you need to use standard protocols, right? So the protocols have what we call southbound protocol, meaning from the controller to your forwarding device. You know, in this diagram, I actually show is for a cloud data center, So that means that the forwarding device is basically your host, right? So some component, some forwarding device in the host, right? Not the individual VMs, right? It could, if you deploy in other areas of the network, it could be a router, it could be a switch, right? It doesn't matter, right? So what happened is that all these protocols down here between the controller and the host, what we call the southbound interfaces, right? You have OpenFlow, which I talked about just now, right? You also have other protocols, and one of them is XMPP, which we are using, right? But it doesn't really matter because there are a lot of protocols that you can use. It's just a matter of what makes sense. But it has to make sense to use it at the location, right? And then going up, obviously you need to provide some APIs, right? You have a controller. While Juniper can provide you with a custom management system, you may want to integrate with your own OSS, BSS, or your own DC orchestration tool, right? So you need to have some well-defined northbound interfaces, right? So in our case, we use RESTful interfaces. So we just need to provide the APIs, and you can easily connect to it, right? And it's important because once you start to use anything that's proprietary, that's it. You are locked into whichever vendor you're using, right? And then that really defeats the purpose of what SDN was coming was. Is because just now I said, SDN allows you to use any vendor's equipment, right? So if you were to use some interfaces anywhere that is proprietary, then that's it. You're stuck. Right? And lastly, basically, start off with data center, and then learn how to apply it, and then start to deploy it at the other places, right? You can do it in your campus network. You could do it in your edge network. It's for a service provider, your edge or the core network, right? So just a quick recap. The six different principles, right? Basically, once you separate the plane, you can do a lot of optimization, right? You centralize what you need to centralize, right? Decentralize what you should decentralize, right? And then use cloud techniques to deploy services, right? If you can, right? Most of the time, it will be what we call firewall services, DPI services, whatever, right? Basically, all the services that my colleagues have talked about earlier today, those can be virtualized, right? So use those techniques, right, to deploy like a cloud service, right? And then have a common platform, right? And also use basically open protocols, right? And finally, deploy wherever you want, right? And what Juniper is doing, right? I did mention about 4 steps, right? 4 steps. So the very first step is basically management. You need to come up with a management platform, right? You can use your own management platform, right? Because if you already have one, we won't force you to use another one. We will provide you some other interfaces, right? But if you want to use ours, we have a management platform, right, for you to basically orchestrate the entire network, right? And that particular so-called management platform for Juniper is actually called Juno Space, right? It's a product called Juno Space. So there's a couple of modules basically to Juno Space. At the base, we have a Juno Space platform, right? So it's basically a platform that is going to do all the element management and stuff like that, being able to find out what's the topology of the entire network, things like that. And on top of the platform, we can build applications. Juniper have applications that we build on top of it to provide network management itself, right? We have a security director to provide management of all the security devices, right? We have a network director to provide management of all our switching devices. Doesn't matter which EX, QFX, whatever, right? So we have other different type of applications, okay, that are running on top of this Juno Space, right? And if you already have your own orchestration tool, but you still want to use Juno Space, we provide you the SDK and APIs, basically, right? So you can actually integrate it into your existing infrastructure, right? Obviously, that will require some kind of software development work to be done, right? But it's possible. So the second thing is regarding extracting its services, right? Like what Greg mentioned just now, most of our security services are available in appliances or available in a virtualized form, right? And one of the big pushes of doing doing all the services in virtualized form is actually a lot of service providers, right? They came up with a white paper on what they call network function virtualization, right? Where they want vendors to basically virtualize all these services, load balancing services, firewall services, DPI services, whatever. They want it to be virtualized so that they can deploy services very fast. And once the user don't want the service, they can remove it equally fast, right? Because if you put a box there, how long it take for you to buy a box? A couple of weeks maybe, right? If the customer don't want the box and don't want the services anymore, what happened? Well, you can't give back to the vendor, right? So you have to keep it. So what they really wanted was to do that, right? So and Juniper is basically developing virtualized versions of all our security services, right? Security products we are going to virtualize, and not just that, we are also going to enable our partners. I mean, we are not the smartest, right? So there are other people who can do the better job of doing certain things. So we are also going to allow them to actually put their services onto our system as well, right? So we can run really on any x86 servers. There's not a big deal, right? But we also allow this kind of virtualized services to run on our router as well. Our MX router have a special card that you can actually run all those services, right? So very, very flexible, right? Right. And the third part is basically centralizing the controllers, right? What Juniper did was, in the beginning, we don't really have a controller as part of our solution, right? And in December last year, we bought over a company called Control Systems, right? So Control Systems basically provides us with a controller, right? And the thing is, before we take over Control Systems, they are an end-to-end solution for a cloud. I mean, an end-to-end cloud solution, right? That means that they actually have the management piece, they have the controller piece, and they have a little piece of hardware that's for forwarding that sits inside the server itself, right? So right now today, if you are familiar with VMware have a vSwitch inside, right? In fact, most of them have something similar to a vSwitch inside the network, right? So control system, basically when you look at when the designers of the product, they look at it, they decided they need to define new ways of doing things, right? And so they came up with IETF draft, right, of how to implement this little forwarding piece, right? If you're interested, I can give you the IETF draft. You can take a look on how things are done, right? But this basically is sort of like replaces the vSwitch, right? And it's basically like a router, little router that's here, that does everything in L3, right? And then how the entire system works is basically part of the draft, which I won't go in detail. If you need to know, let me know. I'll tell you what draft is it, right? So that particular controller basically is able to communicate directly with this forwarding piece here, which we call the V router. vSwitch, because it's L3, we call it V router, right? And basically being able to control this guy to tell him how to forward traffic, right? As simple as that. Yes, it's a kernel module that sits on the hypervisor, right? So today we support KVM, right? We are going to do support for other hypervisors as well. I mean, not today. I mean, when we announce our product in the third quarter, right? It will support KVM, right? So other hypervisors will be later. Okay, but this thing it's a technology, right? That is open, is part of a IETF draft. You can implement it. So technically speaking, if you want to implement it in a switch or a router or whatever, it's possible, right? It's not necessarily need to be on the server here, right? But the reason why why they chose one of the reasons why they chose to start off with KVM was that a lot of service providers in the cloud environment actually uses KVM. KVM or Zen, basically. A lot of them are using that, right? So that's why they started off to provide this as a complete cloud solution that ISP or a big enterprise can actually use to provide end-to-end cloud solution, right? So one of the important thing is that this part is your data center network, right? I put down there, it's written down there as IP fabric, right? So it doesn't really matter what kind of which vendor's equipment you have in there, it doesn't really matter, right? As long as it supports IP, which every switch and router does, right? So it's more of a being able to deploy this solution regardless of what kind of network infrastructure you have today, right? So just now I talked about 7 myths of the SDN, right? Actually lately there's another myth that came out just very recently. Is that is number 8 myth. It's basically people are saying that, oh, to deploy SDN I need to rip out my entire network and replace it with a new network that can be SDN enabled, right? But you don't need, right? Actually, you don't need, right? So technologies are there to allow you to do this kind of things, okay? And just now, Greg did mention about service chain, right? Service chaining. So how SDN helps in doing all this service chaining is basically from the controller, because he knows where the traffic is supposed to go to, right? He has the idea, right? And then what he does is that he's going to tell every individual V router how to forward the traffic, right? And since he knows that this service this particular traffic of this user needs to go into this particular service, and then after that the second service, and before it goes to somewhere else, right? He just need to program all these guys and tell them exactly how to forward the packet, and that's it, right? So it makes things a lot simpler. The OPEX part becomes much cheaper because you can do a lot of things automatically, right? It's like a supercharged OSS, if you call it, right? But it makes things a lot easier because it integrates a lot of all this, how this guys forward traffic basically is through some interaction with the control plane, right? So how the control plane know what to do is because you have an orchestrator up there. Basically, your management system, right? They say that I define all this. These are the policies. When you define the policies, you bring down to the controller, and the controller is going to do the rest, right? And one of the good thing about our the solution that we're going to launch in the 3rd quarter is that because this guy, right, is the guy that takes in all the traffic. Traffic from the VM is going to go through him. Traffic from the network is going to go through him. Everything goes through him, right? So if you need to do troubleshooting, you need information. If you need to do billing, you need information, right? Bits per second or packet per second, whatever. Where else to get all this information than this guy, right? So what happened is that our system also includes what we call the analytics portion in the controller, where we actually get all this statistical information back into this guy. And then from there, you actually can have all this information to look at the flows, for example, to do troubleshooting, look at the route table here, whatever. So those are the things additional things that can be done as part of an entire SDN framework, okay? And lastly, this one I talked about just now, that you need hardware to complement your software, with the example I'll give you about the CPU, right? So I probably won't go into deep detail, right? So just a recap, the 4 steps of SDN, right? Management, extract the services, the controller, and then the hardware. What are the things that we are doing? So Juno Space we have, right? And then extract the services. Actually, this is a name we give it to the product that we can actually do network function virtualization. But the virtualized network functions, could be a virtualized firewall, virtualized DPI, whatever, right? Yeah. And then on the controller, we have our control system, SDN system, right? And then on hardware, we are continuing to put R&D dollars into our switching portfolio, right? QFX, QFabric, EX series switches, MX series routers and stuff like that. Okay, and on security, right? A lot of people start to also talk about SDN. Then can I do SDN for security? Right. So most of the time when people talk about SDN and security, they are usually looking at two different places, right? So the first is basically talking about how you secure your SDN framework. Now everything is done by the controller, right? So now if your controller get compromised, then basically you have a lot of problem, right? And the second thing is how to use SDN to provide security services. Right, and that's where basically service chaining comes into play, right? So the security infrastructure, I'll probably skip this because it's basically just about how you make sure that your controller is secure, right? Basically, between controller and your equipment, you need to have some kind of authentication, right? Just like today, router and router, you run BGP. Or SPF, you do MD5. Same things, right? Things like that. So those security knowledge, okay, that you have in today's network and how to secure the infrastructure will apply. Same thing to what you have in SDN today, right? So the second is basically to be able to provide security services, all right, using SDN, right? Like I mentioned just now, service chain is how we do it, right? So imagine you have a user, right, that runs a web server, and then he wants from you, I want to have a DPI service and a firewall service to protect my server from my users who are coming from the internet, right? So basically, you can actually use SDN to basically put a profile and say that for this particular server, anything that's coming in through internet to this server, I need to chain it to go to a firewall first, and then a DPI, and then after that I hit the server. And these are all rules that you set in your management system, right? It could be a portal for the user, just click, 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 and then you launch. It could be that as well. Right? So it's because everything is software, right? So a lot of things can be done, right? But the underlying hardware layer, you have to make sure that it supports what you want to do, right? So that's basically what I'm going to cover. I hope I've given you a brief overview of what SDN is, what Juniper's view of SDN is, right? And then come the third quarter, well, we'll launch our SDN product. Maybe at the time, if you are more interested, right, look for any of the Juniper sales guys here, right? Thank you very much.